In pure mathematics, proving the existence of a non-sophic group is an open question that has successfully stumped human experts since 1999. That 27-year streak of failure ended when an internal version of OpenAI's upcoming Astra model generated explicit, verified mathematical proofs for it, along with 9 other complex problems that had each gone unsolved for at least a decade. Generating those 10 breakthroughs consumed roughly $2,000 in total computing time. The model produced advances in highly abstract, rigorous fields, von Neumann algebras, sphere tacking, and circuit complexity. Mathematicians are openly comparing this moment to 1997, when the Deep Blue supercomputer defeated Garry Kasparov in chess. By producing verified original proofs, artificial intelligence has moved past retrieving and summarizing human data. It is now synthesizing net new truths. This chart illustrates a rapid collapse in the price of raw artificial intelligence. DeepSeek's newest model offers high-tier performance for about 14 cents per million input words. Because computing power has gotten so cheap, the software industry assumed the path forward was obvious: throw massive amounts of processing time at local AI agents to force them to be accurate. But a recent paper published on Archive tested exactly that and found that giving local agents more thinking time offers severe diminishing returns. Extra computing power largely just shifted how the agents failed, causing them to stall out or confidently report false successes. Progress is no longer coming from scaling up raw power. The industry is finding that elegant constraints actually produce smarter models. Explorative modeling demonstrates this perfectly. The AI makes several attempts at a single task, but only its absolute closest guess is used to teach it. By learning from a single, precise attempt, this method requires 6.2 times less data, producing significantly sharper results. Breakthroughs now stem from this kind of hyper-efficient precision, finding gains in selectivity where brute force has reached its limit. But even a highly efficient intelligence will fail if the software tools it uses to access databases and interfaces are poorly designed. Microsoft released an open-source language called Flint to fix how AI interacts with data visualization, stopping agents from blindly breaking formatting options. Flint gives AI a high-level vocabulary to describe a chart, handling the tricky technical details automatically. The standard for AI connections, the Model Context Protocol, is undergoing a massive reduction. It strips away complex handshakes in favor of a single request. The server no longer has to remember any previous sessions. Because tools answer one narrow request and immediately disconnect, the connection is significantly easier to audit. This cuts the risk of prompt injection attacks and data theft. Dependable AI requires simplifying the hidden plumbing. When agents are handed strict, well-designed controls instead of 1,000 different knobs, they stop breaking things. As these capable models become ubiquitous and easy to integrate, organizations are struggling to track exactly how much they are spending on them. The popular AI coding editor, Cursor, recently sparked a massive backlash by removing cost columns from user dashboards. Exported spending files now retroactively display $0 and 0 cents for all historical data, wiping out corporate visibility into past billing. There are deeper friction points beyond accounting. When OpenAI integrated agents into their company chat system, employees actively refused to help when an artificial avatar reached out with a request on a human colleague's behalf. No matter how flawlessly the code executes, deploying these systems inevitably collides with messy human boundaries of trust, social norms, and economics. To bypass human limitations, Astra provided machine-checkable proofs using the Lean-4 verification system, ensuring every logical step was structurally sound and verified by software. Human researchers then took those machine-verified steps and refined them into finished, published manuscripts. The software supporting this work is compounding quickly. Tencent's new Agent Memory project allows teams of agents to pool their conversation history and code into a shared hub, meaning they can share context across sessions rather than starting from zero every time. The brute force era of scaling massive, inefficient models is ending. It is being replaced by elegant, highly targeted systems that require less data and less energy to invent completely new solutions. The limit of AI is no longer the data we provide, but the ambition of the questions we ask. We have given the machine the tools to build the truths we haven't yet discovered.